Okay, here we are back with more one-step equations. I'm going to move down to a different type of equation this time. You'll notice this is a subtraction problem. And if we go back over to recognizing subtraction, it's a number with a minus or a negative sign in front, like this or like this, even if it comes first in the equation. So you'll see I have an example of each here. Even though this looks like an addition problem, it is and would have to be done by, like, undone by subtraction is actually has to be undone by adding this 5 back to both sides, but we'll get to that in a second. So here it's a little more straightforward. We had 2 taken away from n. We want to undo that by using the inverse operation. The inverse of subtraction is addition. We're going to add the 2 back, and in order to keep our equation balanced, we have to do that to both sides. N minus 2 plus 2 is just n. 4 plus 2 is 6. And then we have our answer. We can check that by putting n back, 6, back into the equation where n was. 6 minus 2 equals 4. Is that true? Yes. So we have gotten it right. Going over here to this example. Here we have a positive n and a negative 5. And so we want to add 5 to this side so that we can get n all by itself. I'm going to add 5 here and add 5 over here. So this brings us up to 0 plus n, or nothing plus n, which is just n. And 2 plus 5 is 7. And then to double check, again, we can put 7 back in place of the n. We have 5 plus 7. Does that equal 2? It does. So we're correct. Okay, next we're going to go through an example of a multiplication and a division problem. So here we have negative 6n equals 12, and we want to undo that by using the inverse operation. The inverse of multiplication is division, so I'm going to divide both sides. I'll use the fraction bar to show that I'm dividing, although some people will do the standard division symbol. So I want to divide both sides by negative 6 because, like it says up here, we're moving away from the variable, so whatever number is with the variable, that's the number that I'm going to be using in my steps to solve. So like here we had 2 with the variable, that's the number, or the digit, the numeral, I guess, because we have opposite signs here, and here it was 3, here was 8, so it's whatever is with the variable. So we're going to divide both sides by negative 6, and negative 6 n divided by negative 6 is just 1n. We don't have to write the 1. 12 divided by negative 6 is negative 2. And then we can check it. Negative 6 times negative 2. Negative 6 times n. Negative 6 times negative 2, because negative 2 is n. Does that equal 12? Yes, it does. And finally, an example of how to do a division. So we have n over 2, or n divided by 2, equals 4. We want to undo this by using the inverse operation. So if this is division, undoing it would mean that we have to multiply both sides by 2. And that's a little strange because I know I always am like, use the dot for multiplication, but when it's written vertically like this, it just seems weird to use the dot to me, so I use the little x. So n divided by 2 times 2 is just n. 4 times 2 is 8, and that's our answer. And we can check it if we put 8 back in place of n in the original equation. So 8 over 2 equals 4. And is that true? Yes. 8 divided by 2 does equal 4.